Okay.
So say prove by contradiction that the equation this has no integral roots, right? So we can see contradiction means you have to show somewhere some contradiction that okay, there is a contradiction in our assumption, there is contradiction in this well-known result, right? So integral roots. So how many types of integers we have? Basically, broadly, we will have two kinds of integer. Basically, there are three kinds
Real.
of integer: positive, no, all are real, positive, negative, and zero, right? So we are
Yeah.
considering suppose, or we can say even and odd, right? We can say your integer will be either n is equals to even, or we can say we can have it as odd. Am I right? So
Yeah.
let us suppose, see, we have to prove it by contradiction. So what we'll write? Let, if possible, we have the integral roots. We have integral roots, right? We have assumed that if it is possible, then we can assume that we have some integral roots, say n. N is our integral root. Say n is integral root. Is it okay?
Okay.
So since this is the root, it must satisfy this equation. Am I right? This
Yeah.
n should
Yeah.
must satisfy this equation. So I should write
Yeah.
3n cubed minus 7n squared plus 5 should be equals to 0. Now
Yeah.
we have to do
For that
something.
value of
Yeah, we have to do something which creates some contradiction, some controversial statement we have to prove. So see what we can do. We can do 3n cubed plus 5 should be equals to 7n squared. Can we write this?
it. Yeah.
Now, since we are saying that n is the integral root, so as per possibility, my n will have two situations. Either n is your even, n belongs to your even, or your n belongs to your odd. Am I right?
Okay.
If n belongs to your even, then can you tell me n cube will be what? If you have some even number and if you're doing cube, so obviously this will be an even. Am I right?
Yeah.
Now, 3n cube will be what? If you multiply, see, this is an even number. N cube is an even number. So, even into odd. For example, 4 into 3. Again, even 12. Am
Yeah.
I right? Now, 3n cube plus 5. See, this whole thing is an even number, right? We have proved that this whole thing, this 3n cube is even. So, even plus odd. See, 8 plus 3, 11. That is the odd. So this is an odd number, right? So it means right
Yeah.
now my left hand side is an odd number. Do you agree with this?
Yeah.
But please see
But your
the
right hand side is
even, right?
even.
See n square, since n belongs to your even, we are working in this case. So n square will be belonging to your even also. 7n square will also will be your even, right? So see, this is odd
Wait,
and
how
this
do
is
you know
even.
n belongs to even from the start?
Sorry,
How do you know n belongs to even?
you are not listening my statements. We have considered two cases. We are working in the first case, first of all. Your n will have two possibilities only. Either it's even or odd. Anything else will be possible.
No.
So we are working in, we will work for both cases, one by one. So right now we have proved that n belongs to even will not be possible. Why? How? Because an odd number can never be equals to even number. Am I right?
Yeah.
Now, same process we will do for n belongs to odd also. So if your n belongs to odd, so what will be n cube? Now we are working for n odd. So you can take some example. For example, n is equals to 3.
Odd.
So obviously this will be odd. What will be 3n cube? Odd into odd. 5
Even.
into 3. Are you sure? Odd into odd
Okay.
even.
Odd.
Odd. 3n cube plus 5. Odd plus odd. This is also odd. This is also odd. So
Even.
even. So this will be your even now. Whereas, see, n square will be your odd. Similarly, 7n square will also be odd. Is it okay? So see, in this case, your left hand side is your even expression, whereas your right hand side is your odd expression, right? So do you think that they can be equal for any case? No. So
No.
we have discussed both the possibilities for n. Either your integer can be even or odd. but none of the case is satisfying this equals to condition. So it means there is a problem in our assumption. It means we can say that this equation can never have integral roots. That's the proof. Any doubt?
No.
Okay, very good.